Think about it for a second. From the way your pocket money might grow if you save a little each week, to the perfect number of petals on a flower. Our world is literally full of these predictable, repeating patterns. But what if we could do more than just notice them?
That's the real question, right? Can we use the language of math to not just see a pattern, but to actually predict what's coming next? Well, the answer to that is a huge yes.
Hey everyone, in this explainer, we are going to completely master the full chapter on progressions. By the end, you'll have all the tools you need to decode the patterns all around us. So here's our game plan. We'll start by understanding what progressions are. Then we'll dive deep into arithmetic progressions, or APs, and solve the classic exam question. After that, we'll tackle geometric progressions, or GPs. We'll wrap up with a master summary of all the formulas, and then it's your turn with a revision quiz. Ready? Let's get started. Okay, first things first. Let's bridge that gap between just seeing a simple pattern in what we in mathematics call a progression. It's like we're learning the secret language of sequences. Let's ground this with a real-world example you will definitely see on your exams. Imagine you invest 1,000 rupees, and you're getting a simple interest rate of 8% every single year. So how does that interest actually grow? Well, at the end of year 1, you've earned 80 rupees. By the end of year 2, that's up to 160. Year 3, it's 240. Are you seeing the pattern here? Every year, we're just adding another 80 rupees. This consistent adding, that's the absolute key, and it leads us straight to our first type of progression. And that brings us perfectly into section 2, arithmetic progressions, or what we'll call APs for short. This is just the official math term for patterns that are built on these constant, steady steps. So here's the crucial point. An AP is simply a list of numbers where you get the next term by adding the exact same fixed number every single time. And we call that number the common difference, or just D for short. So in our interest example, D was 80. Simple as that. Now, let's see how we can build a master formula from this. If we call the first term A, then the second term is just A plus 1D. The third term is A plus 2Ds. See that? For any term you want, let's call it the nth term, you just take the first term A and add the common difference n minus 1 times. It's always 1 less. And bam! There it is! This is the key formula for arithmetic progressions. The nth term equals the first term plus n minus 1 times the common difference. It's simple, it's powerful, and you absolutely have to know it for your exams. All right, enough theory. Let's put this formula to work. Moving on to section 3, we're going to see how this thing solves a typical board question. This is where the knowledge becomes power. Here's our problem. Find the 15th term of the AP. 3, 8, 13, and so on. Let's get to work. Okay, step 1, always, is just to identify what we know. The first term, A, is clearly 3. The common difference, D, is what we're adding each time. So 8 minus 3 is 5. Let's just double check. 13 minus 8 is also 5. Perfect, D is 5. And the term we need to find, N, is 15. Step 2, write down the formula. Seriously, this is a great habit. Just write out AN equals A plus N minus 1D. It helps prevent mistakes, and it shows the examiner you know exactly what you're doing. And now for the fun part, just plug in the numbers and solve. The 15th term, or A15, is 3 plus, 15 minus 1 times 5. That simplifies to 3 plus 14 times 5. We know 14 times 5 is 70, so we just have 3 plus 70. Which gives us our final answer, 73. The 15th term in the sequence is 73. And just like that, you've solved a classic exam problem. See? Once you have the formula, it's just a clear, logical path to the solution. So we've mastered patterns that grow by adding, but what about patterns that grow by multiplying? Think about how compound interest works, or how a video goes viral. That brings us to our next major topic, geometric progressions, or GP. The definition is going to sound really similar, but with one crucial change. Instead of adding a common difference, in a GP, we multiply by a fixed number to get the next term. And this number is called the common ratio, or R. And this, of course, leads to its own key formula. If the second term is the first term A times R, and the third term is A times R squared, you can see the logic, right? The exponent on R is always 1 less than the term number. So for the nth term, it's A multiplied by R to the power of n minus 1.
It's that exponent that makes GPs grow so incredibly fast.
Okay, that was a ton of information, I know. So let's consolidate everything in section 5. Think of this next slide as your master cheat sheet right before an exam.
This slide is pure gold. For APs, remember, constant addition, the key variable is the common difference d, and the formula is a plus n minus 1d. For GPs, it's constant multiplication, the key variable is the common ratio r, and the formula is a times r to the power of n minus 1. Go ahead and screenshot this, it's the perfect revision tool.
And now, it's your turn. The absolute best way to learn this stuff is by actually doing it. So I'm going to show you some problems, and I want you to pause and try to solve them yourself.
We already did number 1 together. Number 2 is interesting. It asks, which term of a decreasing AP is negative 81? Number 3 tests your GP skills. Number 4 is a classic tricky question, how many 3-digit numbers are divisible by 7? And number 5 asks you to find the sum of a GP. So take your time, apply to formulas, and see what you come up with.
And as a final thought to leave you with, now that you have these tools, start looking around you. What other real-world patterns can be described by progressions? The bounce of a ball, the growth of bacteria, the math is everywhere. Now you just have to find it. Thanks for watching and keep exploring.